So we're talking about, or we were talking about, the command structure in Linux. So how do you use commands? Right, and you saw that commands have options. They sometimes have options. They sometimes have arguments. Right, usually when you're using commands, they have both. So for example, the cowsay program has a bunch of fun options. So if you type man cowsay, you can find the man page for the cowsay program. Where? This one. Right, the point of this the point of actually doing this is to show you that there is no standard format for the man page of a command. Whoever writes the man page can write it however they want. And unfortunately, whoever wrote the cowsay program, they wrote it so that there's no easy way to scan the document and see what the different options do. Right? Most commands, they list all the options for you, and then if they need to, they'll describe the options in greater detail later on. Here, whoever wrote the man page buried all of the options inside the text. So sometimes it's annoying to read the man page. Eventually, though, if you actually do read all of the man page information, you'll see down here, right, the -F option lets you choose what shape to draw the cow with, right? And if you want to know what shapes are available to you, right, after more reading, you can see that, hey, if you use this -L thing, you can list all of the possible cow shapes. So that's fun. So let's do that. So cow, say, -L, right? And you can see here that you can draw a cow or a frog or a rabbit or Calvin, as in Calvin and Hobbes, and lots of other things, right? And so now you can do cow, say, -F. What's a good one? Ghostbusters. Ghostbusters, hello. And now you get a different output from the cowsay program. Right? Some of these are slightly naughty, I guess, so I'm not going to do them all. But yeah, so that's how reading a man page can be useful. Stegosaurus. Did I spell that right? No. How do you spell Stegosaurus? Stegosaurus. And there you go. Right. Okay. Now, when you're using commands from the console, so a lot of the time when you're doing stuff on the console, you're typing in some commands, you're looking at the output of the command, then you're going to do something else, right? Probably type in another command, look at the output, do something else, right? And after doing a bunch of things, you'll realize there's this, I did something maybe 1 or 2 or 100 commands ago, and I don't quite remember how I did it. Right? And so that's what the history is useful for. So most of your bash shells are probably configured to remember some number of previous commands that you typed into the shell. Right? And so for example, if I type history in my shell, I'm just going to do history, it lists what looks like, I don't know how many it actually lists. I don't know, I think mine's configured for 500 or 1,000 commands. But it lists all of the commands, well, the number of commands that you specify, that you have in your history file. It lists the history of those commands. Right? And it has a number beside each one of them. Right? So you can see here, the command that's numbered 2149, right? That's when I typed in cowsay -L. Right? You can see that I've been busy, right? I've been typing in a bunch of stuff, right? And so this is useful if you, especially when you type in some rather long sequence of commands, or if you start to use a command for the first time, you don't remember how you did it. Right? And so when I generate your assignments, the program that I use to generate your assignments has lots of inputs to it. And I can never remember how I do it because I only do it every 2 weeks. And so I have to go back and remember, I have to go back in the history and look how on earth did I do this. Right? And so that's useful. So you can repeat a command if you have the history by typing ! And then the number of the command that you would like to repeat. So I'm going to repeat command 2149, right? And that's going to redo cowsay -L. Right? So your shell remembers some number of commands that you typed in the past. It's often useful to go back and look at the command so that you can see how you did something at some point in the past. I don't know what the default number is. And I don't remember how to find out what it is either. Okay, the shell, when you're using it, also has something called tab completion, which is really, really useful if you do a lot of work on the command line. And so the way this works is, well, it works in a few different ways. If you start to type in a command, so I start to type in COW, and then press tab, the shell will automatically complete the command, right? So, boop, boop, boop. So if I COW and type tab, so it does nothing. If I type it again, sorry, twice, there we go, right? It will actually list all of the commands that it knows of that start with COW, right? And so if I type COWS, oops, sorry, I have the caps lock on, S, and then type tab, it'll auto-complete the command, right? Which is handy. So if you start to type in some command that happens to have a long name, you normally only have to type in the first few characters and then press tab, and it auto-completes, right? Obviously, if there's more than one command that starts with the same few letters, it can't auto-complete. But if you type tab again, it'll list all of those commands. Right? Now, this also works with file names, right? So if you start to type in a path name, right? So for example, ls root user games cow, and then press tab, something will happen, right? So ls root user games, right? Games. Oh, there I just did it. So if I type in user g, right, and press tab, it auto-completes to games because there's only one directory that starts with G. There's only one file that starts with G in the user directory, right? So it auto-completes. Now if I type in cow, press tab, nothing happens, but if I press it again, it'll list both of the completions, right? So now I can type in cow t and then tab, and it auto-completes the file name. Right? So this auto-completion feature is really handy when you are doing lots of work on the command line. What does user games p do? I don't know. Let's see. So ls root, so usr, g tab, p tab. Oh, I guess it's Pac-Man for console here, which won't run on here because my font's too big. So, but that's auto-completion. All right. So when you're looking up help for a command, if you're using the man pages, right? Sometimes you'll run into a situation where you get the wrong man page. And the reason this happens is because you can have two commands with the same name, right? And so when you type in man and then followed by the name of the command, you might end up with the man page corresponding to the wrong or corresponding to the command that you're not looking for, right? And so the man pages are divided into what are called sections, right? So 1 through 8, right? You don't need to remember what the section, no one remembers what the sections are actually. Well, at least I don't, right? And so sometimes, oh, sorry. Okay, where do I have there's an example. Oh, I don't have it here. Man is an example of a command, which is somewhat ironic, where you get the wrong man page. So if you type in man to get help on how to use a man page, you end up, oh wait, do I end up with the right one? Oh, I end up with the right one here. Okay, so never mind. I thought I ended up with the wrong one. That's funny. Okay, so I guess you end up with the right one here on my current configuration of Ubuntu. Sometimes you have to specify the actual section in which to look, right? And the way you do that is with a flag. So man, and then the section number. Right? So let's see if we can just. I'm just going to scroll to the end here. See also. So at the end of at the end of the standard man pages, there will be a section of related commands. You can see here, there's another man page in section 7, right? And so if I type in man 7, I get the man page for the other section, right? Which isn't useful for us here, right? But occasionally, every once in a while, you will come across a command that has the wrong, you'll come across a man page for the command that you're not looking for. You're looking for a different command of the same name. Typically, if you scroll to the bottom of the man page, you'll find the section number of the other command that you're looking for. Oh, I guess printf is one of those. Hang on, printf, you probably get the, okay, so here you get the printf command for bash. There's also a printf command in C, which is in section 3. So if I do man3 printf, I get the documentation for the C function called printf. This is a bit weird. So my man pages aren't behaving the way I expect them to. Anyway, it's fine. All right. So at this point, you should, a lot of work that you do with the shell involves working with files, which is just the way it is, right? So this is a bit of a weird course to teach because typically most users of their computer systems, you're not working with lots and lots and lots and lots of different files all the time. Right? System administrators do, right? Because so a system administrator, they might have to manage a computing system with hundreds or thousands, tens of thousands of users, right? And so all of those users, they're just a file somewhere on a system. So they have to deal with files all the time. Typical user, you're not really dealing with lots of files all the time. Right? But because files are so important in the Unix and Linux operating systems, there are ways to shorten file names or to specify groups of files. Right? So one of the mechanisms are called wildcards. Right? So the shell provides special characters called wildcards that let you succinctly specify groups of files. Right? These are also called globbing patterns. So if you ever see the term glob in the context of Linux or Unix, then they're talking about these wildcards. Notice well, let's try it, man7 glob. So let's try man glob and see if I get the right thing. Glob. Okay, so here, this is an example of where you get the wrong thing. So if I type in man glob to find out information about wildcards, right, I instead get the man page for the C function of the same name, right? Now you haven't taken much, most of you haven't taken any C yet, so you don't actually recognize that this is a C function, right? If I type in man7 glob, that's when I get the information about wildcards. Right? So if you ever forget how wildcards work, man7 glob, and it's here. Right? Of course, now you have to remember man7 glob. But anyway, right? So you see here the character question mark star and the opening square bracket, these all have special meanings when you use them in a file name. Right? So the symbol star or asterisk will match any number of characters. I'll show you examples. It's way easier to see examples of these than just to read the text here. Right? The question mark will match any single character. Right? If you use square brackets and then put some characters inside the square brackets, that will match any one of those characters inside the square brackets. Right? Not, and then a bunch of characters, will match anything that's not equal to one of those characters. Right? And then you've got this funny double square bracket colon notation, which I'll show you shortly. Okay, so these, by far the easiest way to learn these is just to try it out, right? So I've got a bunch of examples here. Now, these are meaningless unless you actually have some files to work with. So let's look at some files. Right? Okay, so before class, I just made up a bunch of silly files. Right? So you can see here, I've got some files. Well, let me list them in one column so that you can see them a little better. There we go. Right? So these are just, and these are for the most part, these are just files with one line in them. Right? So they contain one line of text, and they have these names. Right? So 01.pdf, 99.pdf, all the way through xzz. Right? If you actually, so when I look in one of these files, so if I list the contents of one, so let me list the contents of moo, right? Then you'll see that it prints out this is file colon moo. Right? So in other words, each one of these files, there's just one line. That one line is this is file colon and then the name of the file. Right? And so this is for illustration purposes. Right? Okay, so I've got a bunch of files, right? Some of them are made up of 3 characters. Some of them start with a number, right? Some of them end in .pdf. Some of them end in .txt, right? There's all sorts of patterns here that you could exploit, right? So if I want to find, what if I type ls star, right? So what does that mean? So the star means match any sequence of characters, right? Almost any sequence of characters, right? And so what does that mean? So star will match 01.pdf, because that's any sequence of characters, right? It matches 99.pdf, because that's any sequence of characters, right? And it matches xzz, and everything else that's there. Right? So if I type ls star, I get the exact same output. The star expands. So we say in bash, the star expands to all of the things that it matches in the directory. Right? So the star matches, it expands to all of the file names in the directory that you have. Right? So in other words, that star, so typing ls star is the exact same thing as if I typed in ls space 01.pdf space 99.pdf space moo space a space, and so on and so on and so on for every file in the directory. Right? What the star doesn't match are the hidden files. So there is a hidden file in this directory. Right? Remember capital A, almost everything, including the hidden files. Right? There's a hidden file, .ab. Right? So the question is, does the star, right, I told you it matches any string. Does it also match a string if it corresponds to a hidden file? Right? Well, ls minus a star. The answer is no, it does not. Right? So the star does not expand to match the hidden file names. Right? So that's the one thing it doesn't match. Right? Anything that starts with a dot, it won't match that. Unless you can change your shell so that it will match it. Right? But by default, it doesn't match. So that's the one thing it won't match. Right? Which is weird, right? ls minus a, I see the hidden file. Right? As soon as you type ls minus a star, right, you have to remember what is the meaning of star. Right? So star expands to match any string as long as it doesn't start with a period. Right? So the star gets replaced with all of the file names of the non-hidden files. And now the minus a doesn't matter, right? Because the minus a doesn't affect any of the arguments. Right? And so if you type that, you don't get the hidden file, which is strange, right? That's not what most people would expect, right? But that's the way that the star operator works. Okay, so what else can you do with the star? So let's look at the files. Right? Suppose I want to list all the files that start with the letter A. Well, ls a star, right? Because the star expands to match any string, right? Including the empty string, but not starting with a period, right? Okay, so a star will match the A because the star matches the empty string, right? It'll expand to match a.pdf, right? It'll match a1.pdf, right? The star matches 1.pdf, right? So if I type that, right, I get all of the files that start with A, right? What about all the files that end with something? So I want all the files that end with .txt, right? So anything, so star .txt, right? Enter, and you get all the files that end in .txt, right? Again, the star matches, right, expands to match any string, right, followed by .txt. Right, so what files end in .txt? Well, that one does. Well, sorry. I have to remember to bring a mouse. That one does, right? That one does, right? There's a third one. Oh, there's two. There's only two, right? Similarly, if I want to find all the PDF files, ls_star.pdf, right? And that matches all the files with the extension .pdf. Questions? Yes.
Did ls.star, would it show the hidden
Yes. Indeed, but it also gives you extra information, which is unfortunate, right? So what does .star mean? So .star means start with a period, so that'll give me the hidden file, right? But what else starts with a period? Unfortunately, the directory dot and the directory dot begin with a period. So you end up listing the contents of dot and dot dot, right? What if I don't want to see the contents of dot and dot dot? Well, let's try minus D, because I know if I type minus D, that only gives me the directory name. Okay, so that works. Minus A says, right, now you might think minus A says list everything except for the hidden, except for dot and dot dot, but it doesn't work, right? Because of now you're using a wildcard, right? So the wildcard overrides the behavior of minus A, right? Because dot star matches dot, and dot star also matches dot dot. So those get listed even though you said minus A, minus capital A as the option. Right? So that's unfortunate. So is there a way to get rid of the dot and the dot dot? The answer is yes, but I believe the question is on the assignment. I believe. It often ends up on an assignment. I don't remember if I asked you this year or not. So I'm not going to show you how you do it. There is a way to do it. Right? All right, what else is there? Actually, you'll probably be able to figure it out by the end, within the next 10 minutes or so. Right? Actually, I showed it to you. One of the tricks is back here. You can use the exclamation mark to solve that problem. Okay, what else do we have here? The question mark. Question mark expands to match a single character, not the empty. There's no empty single character, right? So question mark always matches some character. It can match the space, but it can't match nothing, right? So question mark matches one character, any one character. Right? So let's look at the files again. So I have a bunch of, well, how do I list the characters that have exactly one? The file names that have exactly one character in the name? ls question mark. There you go. Right? How do I match the ones that have two? ls question mark question mark. 3 question mark question mark question. Oh, I forgot to show you something. The up and down arrows on your keyboard, they go back in the history. So up goes backwards in the history. Right? So if I want to repeat the previous command, just press the up arrow once, and that lists the previous command. Press it twice, that goes up. Press it again, it goes up. And again, it goes up. If you press forward, it now scrolls forward through where you are in the directory. Right? So the up and down arrow is also super helpful. What else? How about all the files that start with X and end with Z that are 3 characters long? So lsx question mark, well, sorry, question mark Z. Right? So everything that starts with an X, followed by one character, followed by the Z. Right? Okay, what about the square brackets? So the square brackets let you list a set of characters. Right? The wildcard matching will match any one character inside the square brackets. Right? So X square bracket, Y, capital Y, 1, 2, followed by a Z. Right? Matches X little y, Z, right? Or X big Y, Z, right? Or X1, Z, or X2, Z, right? It won't match X, Y, Y, Z, for example, right? It only matches one of the characters, right? Boop, right? So ls, X square bracket. Oh, I should show you something else too. Y, Y, 1 and 2, followed by a Z, right? Matches those 4 files there. Now, you don't have to just use these in ls, right? Anywhere you would use a file name, you can use the you can use a wildcard, right? So the cat program, remember what cat does, right? So cat moo, right? So cat is short for concatenate, right? So it prints the contents of a file to the standard output, right? So the contents of moo is, this is the file moo, right? cat01.pdf is obviously not an actual PDF file, right? It's just a text file, right? But that prints out, this is the file 01.pdf, right? So if I type in more than one file, right? Cat outputs all the contents of the first file, followed by the contents of the second file, right? So there you go. So what happens if I type cat star, right? It outputs the contents of every file except the hidden file, right? And joins them together. Right? So anywhere you want to use a file name, you can also use a wildcard expansion. Right? So can I cat together all of the 3-card file all of the 3-letter file names? The answer is yes, right? Cat question mark question mark question mark, right? That prints the contents of all of the 3-letter files name, all of the files with 3-letter file names, and joins them all together. Right? So not just for ls, right? You can use this anywhere you would use a file name. Oh, you can use ranges too. So a-z. You have to be careful with the hyphen inside the square brackets, right? So a-z, whenever you use a hyphen, it's indicating a range of some kind. Right? So if you actually want to match the hyphen, right, as a special character, as one of the characters, the hyphen has to appear at the beginning. It has to be the first character, or it has to be the last character inside the square brackets. Right? So a-z means ABC through lowercase z. right? Capital A through capital Z would be all the capital English letters, right? 0-9 would be all the digits. So Control L. All right, so LS, X, A through Z, Z, right? So every file name that has 3 letters starting with X, ending in Z, the middle character is a lowercase letter, right? If you want the middle character to be a digit, then it's 0-9, right? You can combine the ranges, right? So if I want letter or digit, I can write that, right? 0-9, A through Z, right? And that gives you everything that has every 3-letter file name starts with X, ends with Z, middle character is a lowercase letter or a digit, right? So you can combine the character classes inside the square brackets, or the character ranges, sorry, inside the square brackets. You're allowed to use more than one set of square brackets in a file name, right? So 09.pdf, right? What does the first 09 mean? Any digit. What does the second 09 mean? Any digit. So that matches any file name that starts with two digits and ends in .pdf. Okay, there's also these funny things called the character classes. So if you don't want to use a character range, you can use a named set of characters, right? And so the named set of characters, these aren't all of them. These are just these are the very common ones. There are other ones as well, right? So square bracket colon, AL_num, those are all the alphanumeric characters, right? So anything that's a letter or a number, right? If you just want the alphabetic characters, that's just alpha. If you want a digit, that's digit. Lower and upper, lowercase, uppercase. Right. I think if you're in a typical bash shell and you've got your locale set to the standard locale, then everything is in English. You can change the locale of your shell so that it's in some other country, and then these behave in different ways. Right. Okay, so when you use these though, you have to remember, so that's the name of the class, but to use it, that class has to be inside of square brackets as well. Right, so to use these things, they're inside, you have double square brackets, right? So square bracket, colon, upper, colon, square bracket, star. That matches any file starting with an uppercase letter, right? The character classes are a little bit more awkward to use. So ls, square, colon, upper, colon, star, right? So that matches. I only have one file name that starts with an uppercase letter, right? And that's moo. Right. You can, of course, combine these. So I can do upper followed by colon, lower, like that, right? And that gives you moo, right? You can combine them with inside the same set of square brackets, right? So here, I'm going to get rid of that, right? And so now I have 2 character classes inside of one set of square brackets, right? And so this is saying match anything that starts with an uppercase letter or lowercase letter, right? And you get all those. Right. So square bracket, colon, something, that's just like a range of characters of some kind. Oh, good. Any questions about those wildcards? So they're very useful. They take some getting used to. Assignment 1 tries to make sure you get used to them. So there's a lot of using wildcards to match file names on assignment 1. Right. None of the questions are terribly hard, so they're not super difficult to figure out what the pattern is. Any questions? Okay, so the important thing to remember here, though, is that when you use this wildcard, right? So let me do ls x a hyphen z z. Is that good? Yes. Okay. So when you use a pattern, right? What happens in bash is that string here, right? We say it gets expanded so that it matches anything that starts with an X, right? Followed by a letter, followed by a Z, right? And then whatever gets matched, that replaces what I've got highlighted on the screen, So the expansion happens, and then the result of the expansion substitutes for what's highlighted, right? So in other words, when I write that, effectively what happens is LSXAZ, XBZ, XMZ, XYZ, XZZ, right? So that's what happens, right? That line, that thing there expands to that, right? And now ls runs on the expanded input, or the expanded set of arguments. Right? So that's what that's actually called. So when I use these wildcards, this is actually what's called a file name expansion. Right? Cool. So that takes care of that deck of slides. The next deck of slides are the standard streams. So this is dealing with input and output. Okay, so an input stream in Unix or Linux is a stream of data that you can read, right? Or that some command can read, right? So by stream, I mean it's just a sequence, right? So standard input, the stream called standard input is normally connected to your keyboard in a terminal, right? So if you have a screen and a terminal and a keyboard and everything, right, then the stream called standard input connected to your keyboard. There's a stream called standard output. So that's a stream in which output can be written to. Right? Standard output is where most commands write their output to. Right? So that happens to be connected to your terminal, again, on most, if you have a desktop computer. Right? And finally, there's a third stream called standard error. So this is where a command will write any error messages to. Right? It's different than standard output, right? So it's actually a different stream. And this is important because you can send the output of streams to different places, right? So I can send standard output to a file, for example, or I can send standard error to a file, or I can send it somewhere else. And so the error stream is also normally connected to your terminal if you're on a desktop computer, right? So if a command results in an error, oh, there's something else I forgot to show you. If a command results in an error, the error message normally appears in the terminal. What I forgot to show you was what happens if you use an expansion or a file name expansion and there's nothing that matches. Right? So let me look at the. Okay, so I've got a bunch of files here. I've got nothing that starts with the letter K. Right? So what happens if I type in LSK star? Right? And so what does star mean? Star expands to match anything, right? Any string. So are there any files that start with a K followed by any string, right? And the answer is no, right? And the output here is, so now you get an error, right? So it complains, right? ls can't find the file called K star, right? Called K star. Notice that the K star is quoted, right? If you quote a file name expansion, right, the expansion doesn't occur. So lsx, right, star. What about ls quote x star, right? So quoting suppresses file name expansion. Right? Single quotes also suppress the expansion. Right? So when you quote something, right, or when you quote a file name and it has a star or a question mark or a square bracket in it, right, then quoting it says you really want to find the file name that has a star or a question mark or a square bracket in it. Right? So quotation, when you quote something, that suppresses file name expansion. Right? So if you type in an expansion like K star, right, and it can't match anything, then what ends up happening is the result of the expansion is K star, is the string K star. Right? So here, the expansion doesn't happen, right? Because there's nothing that matches, there's no file name that starts with K followed by anything, right? So the expansion fails and results in the string K star, right? Now, ls tries to list the contents of, lists the file called K star, and there is no file called K star, right? And so it prints out, I can't find that file called k star. And it's quoted to tell you it's really trying to find a file called k star and not k followed by any set of characters, right? So if you quote an expansion, the expansion doesn't happen. If the expansion fails, you just get the string corresponding to the, what you typed in. Right? Okay. Oh, and then if you get error output, right? So when it says ls cannot access blah, 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 right? That error message is actually being written to the standard error stream, right? Which happens to be the terminal, right? The output of a successful command, right, gets written to standard output, which also happens to be the terminal. Okay, so each stream has a number, right? Standard input is 0, standard output is 1, standard error is 2, right? And you can use these numbers, which are called file descriptors, for certain purposes, right? Redirection, many commands. Why did I write this? This is an incomplete slide, sorry. I can redirect many commands. That's silly. All right, I'll have to fix this slide. I'll show you what redirection is here. Okay, so do I actually show it? Let me just quickly scroll forward through the slides to make sure I don't have it somewhere else. Oh, no, it's here. That's why. Okay, sorry. This slide's in the wrong place. That's what's going on. Okay, so we'll deal with this in a second. All right, so the Linux, or the Unix and Linux operating systems, they come with many different commands, right? Each command is specialized to do some task, and typically it does the task very well, right? So in Linux or in Unix, when you're doing work on the command at the command prompt, right? Typically what you want to do is you want to run some command. You want to take the output of that command. You want to send it somewhere else, right? So you can string together commands into what's called a pipeline, right? So commands in Linux are like segments of a pipe, right? So I have a command, right? And I can give it some inputs, right? Some arguments, right? The command takes the inputs, does something, and writes the output, usually to standard out, right? So most commands write output to standard output. Right? So for example, ls, right, takes as input, or can take as input, right, the name or names of files to list. Right? So ls root bin, right, takes as input the name of this directory root bin, and it outputs the contents of root bin, right? Whatever file names are in root bin. Right? Input can come from many different places, right? So your inputs can be your command line arguments, right? Or they can come from a file, right? Or they can come from something called standard input, right? So input can come from standard input for some of the commands, right? Now remember, standard input, that's your keyboard, right? So some of the commands will read stuff you type in and then process the stuff you type in. Right? So sort is one of those commands. Now remember what sort does, right? So sort, if you give it a file name, hang on, animals. So I'm just going to make up some animals. I didn't spell that right. Ant, cat, zebra, whale, squid. All right, so if I give sort the name of a file, right, it lists each line of the file and then sorts the lines one by one. Right? So if I sort the animals, I get the animals in sorted order, right? So each line gets treated as a string, then it sorts the strings. But I can also run sort by typing stuff in from the command line, right? So if I just type sort, press enter, and notice that it goes to the next line and you get a blinking cursor. Right, so now sort is expecting the user to type in a bunch of text, right? The input to sort, right? So zebra, enter, right? It's still blinking, so it's still waiting for more input. So whale, still blinking, cat, dog, ant, right? Now what happens if you decide that you're done, right? So how do I tell sort that I'm done with input on standard input. Right? So it's Control D. How do you know it's Control D? Someone has to tell you, right? You have to look it up. So Control D, if there's input from standard in, signifies the end of the input. Right? So when you press Control D, it takes the strings that you wrote and then sorts them. Right? So now you get ant, cat, dog, whale, zebra, which is correct. Right? So if you ever run into a command where you press enter, it goes to the next line and it's blinking and it looks like it's looking for input, it's because it's looking for input from standard in. Right? How do you stop it? Control D tells it that that's all, that you've typed in everything that you wanted to. Right? Calsay will also take its input from standard in. Right? So if you just type calsay and you don't give it a string, it'll say, well, give me a string, please. Right? Hello. Right? Press enter, it wants more. Okay, so goodbye, and then Control D. Control D. There we go. Right? And now it does hello, goodbye. So the command, so outputs of many, not all, but many commands go to standard output, so they get printed to the terminal. Right? Now, what happens if you want to take that output and send it somewhere else? Right? So for example, I want to sort a file, but I want to send that output to a new file. Right? Because, I mean, that would be useful, right? If I have a list of student numbers, right? I don't want to look at the student numbers in non-sorted order, because that's very hard to look at, right? So I probably want to sort them and then save those somewhere, right? Similarly, if I have a list of student names, I probably want to sort those, right? So you can redirect where output goes. You can also redirect where input comes from, right? And so this is called redirection. So if I want to redirect standard output, right, I can write 1, then the greater than sign, followed by the name where I want to send the output to. Right? And you can do this after the command. You can actually do this anywhere. You can do it before the command, you can do it between arguments in the command, you can do it anywhere. It's bizarre. You're allowed to do it anywhere. Right? Most people put it after or at the very beginning. Right? So for example, let's do an example. Well, so the 1 is the file descriptor, right? So remember, 1 is standard output. Right? So for example, do I have an example? Yes. So here, right? So I'm going to list all the files in the current directory, right? And then I'm going to send that output to the file called files.txt. Right? So ls, so it's going to list all those files, right? ls, what did I type in exactly? ls minus a. Okay, that's fine. Right? So ls minus big A. So that's going to show the hidden file, .ab. Right? If I want to save that list of files for some reason, right, I can redirect that output 1 greater than files.txt. Like that. Right? And so now, instead of printing the files to standard output, right? Sorry, instead of printing the files to the terminal, it's going to print to the file files.txt. And you get no output. Right? Why do you get no output? Because I just redirected the output of the command to the file. Right? And now if I list or cat files.txt, right, you can see that that's the output of ls. So ls is a bit funny. If ls sends the output to standard output, then it formats the output differently. Right? So you typically get something that looks like this, where you have multiple files per line. Right? If you redirect it to a file, or if you redirect it anywhere, then it sends the output each file name on a separate line. Right? Unless the file name has a weird character in it, like a new line in it, and then it might span multiple lines. Right? And you can take the output of any command, right, and send it somewhere else. So when you're redirecting stuff, typically you're redirecting standard output. So you actually don't need the number 1, right? If you don't include the file descriptor, right, the shell automatically assumes you're redirecting standard output. So I can get the exact same result, ls minus a, with just a greater than sign, also files.txt, right? And then if I cat also files, right, you get the exact same thing. Right? So if you don't include the 1, the shell assumes standard out. And any command that sends its output to standard out, you can redirect that to a file. Right? So I can redirect calc to a file. Am I going to remember how to type all that in? Probably not. Calc minus fdragon. Oh, notice I need quotes here, right? Because I have spaces. Is that true? Yes, I have spaces in the string that I want to type. Right? So calc produces no output, or at least it sends no output to the terminal, right? Because I redirected it to the file mu.txt. But if I print mu.txt, right, you get the output of the calc program now. All right, so that's redirection. I'm going to show you, I think the pipelines are next, right? Did I do the pipeline? Oh, I haven't done the pipelines yet. So we're going to do pipelining in the next, yes, in the next lecture. Right, so on Friday, I'll tell you about pipelining. And then at that point, you definitely have everything you need for the assignment. Yes?
How would you do it if you wanted to send everything to .text without needing to write it every time you're running it?
Sorry, run that by me again. You want to...
Like, let's say for some reason, like every command I'm going to run in the next, like...
Oh, you want to run all commands and send them to mu. There's no way that... Oh, there is a way to do it. You have to set file descriptor number 1, so standard output, to point to somewhere else.
Okay, so
Yeah.
you can change
I'm pretty sure you can do it. I've never tried to do it. But I'm pretty sure you can do it. Yes. I'm pretty sure you can send you can set where standard output goes to. Yes.
Sorry, I might have missed this, but what does the -f do again?
-f. Oh, so for calc, for calc it says it uses a different file for the definition of the animal or the figure that's printed. Yeah. You don't memorize that. I'm never going to ask you about that, right? I'm never going to ask you on a quiz, right? Write the command calc so that it produces something. You're never going to get it. This is strictly for illustration purposes. All right. Okay, that's it for today. I'll see you on Friday.